last two examples on this page. So we're going to just continue in the same process. So we have phosphorus. Phosphorus's symbol is P, and phosphorus is in the same group as nitrogen. So it's a group 15er, which means it has 5 valence electrons. And so when we place the electrons around and analyze it, we see that phosphorus, like nitrogen, it has 3 unpaired electrons, so it has to form 3 bonds. And we are told the only thing that is present that it can form bonds with is hydrogen. Hydrogen is placed over in group 1. It only has 1 electron. So hydrogen, it's its only electron, so therefore it's unpaired. So the hydrogen has to form 1 bond. Here's the thing. Hydrogen is never a center atom. And if we just look at simple rules, phosphorus has to form 3 bonds. It has to form more bonds than hydrogen, so it's going to be the center. So phosphorus is going to function as the center of our molecule. So I'm going to put P right here. And when I think about the honk rule, because phosphorus is in the same group as nitrogen, I'm going to think about nitrogen, the patterns in which it can form a molecule, and phosphorus would follow or model along. So the first possibility for nitrogen is that pyramidal shape. The second possibility for the nitrogen is that bent shape. And then the third possibility for nitrogen is that linear with the triple. So when I take a look at these examples on the honk sheet, the first one, nitrogen can form 3 single bonds, so I have to add 3 different atoms to it. The second possibility, the bent, I would have to add 2 atoms to it, and one of the atoms has to be able to form a double bond. And then the third possibility is nitrogen forms a triple bond with only 1 other atom. And when I take a look at the information I'm supplied, I have 3 hydrogens. So this is the only possibility for this structure. So I'm going to get my idea down, creating that shape, right? So what happens here, just working through it, my hydrogen I have drawn here, its only electron will pair up with 1 of phosphorus's unpaired electrons. I'm going to place it there. Now I add a second hydrogen. It has only 1 electron, which is unpaired, and its only electron will pair up with phosphorus's second unpaired electron. So I can place it right here. Then lastly, it says I have 3 hydrogens, so here's my third hydrogen, and its only unpaired electron will pair up and form a bond with phosphorus's final. So I will place that hydrogen right here. So each of these dashed lines represent the pairing up of unpaired electrons, 1 from hydrogen, 1 from phosphorus. But notice, phosphorus keeps that electron pair to itself, so we have to put that on top of the phosphorus. And when phosphorus or another group 15 uses this bonding pattern, this is what we refer to as pyramidal. So a pyramidal shape is created. Okay, so the last one is where we've got to think through the process. So here we go. We have carbon. So this carbon, it's in group 14, and so it has 4 valence electrons, and we use that hybrid. So this carbon has to form 4 bonds, right? Now, it also tells me there's a second carbon, so I'm going to draw it in right away so I can see it and not confuse myself. It has the same dot diagram. It also has to form 4 bonds. It's a group 14er. Now, the other element that is present here is hydrogen. Hydrogen has only one electron. It's unpaired, so a hydrogen can only form one bond. So here's the thing. Carbon forms the most bonds. It will be the center. So carbon, most bonds, it's going to be the center of the molecule. So in the honk rule, we look at the carbon. Carbon, because it has to form 4 bonds, there are 4 possibilities of how to get this done. So the carbon can form 4 single bonds. It can form a double bond and 2 singles. It can form 2 doubles, or it can form a triple and a single. And what I've got to figure out is how to make this work, right? So here's the thing. In my structure, I have to have 4 hydrogens and 2 carbons. They all have to be linked into one structure, not 2 different structures. And so I just like to think about it as a puzzle and not try to think too hard. So when you get into these larger structures, one of the things that you need to remember is that every atom has to be linked in, right? And that means they have to be linked in with at least one single bond. So here I go. I'm going to link this carbon to the other carbon. One bond. Now I'm going to take a hydrogen and I'm going to link it to a carbon. This hydrogen is taken care of. I'm going to take a second hydrogen and link it into a carbon, right? If I take this hydrogen and I link it into the blue carbon's last valence electron, this carbon will be happy, blue carbon will be happy, but red carbon will not be happy. So I'm going to take my third hydrogen and I'm going to link it in to the red carbon. So if I take a look, blue carbon right now has 3 bonds, 1 with the red carbon and 2 different bonds with 2 different hydrogens. The red carbon, it has 1 bond with the blue carbon and it has 1 bond with a hydrogen. There's still another hydrogen that needs to be thrown into the link, so I'm going to attach that one to the red. So now I have all 4 hydrogens, each one has 1 bond. My carbons each have 3 bonds, but they each have a single electron left. So that last single electron on both of them will pair up. So when I take a look at the blue, my blue formed 2 bonds with the red carbon and 2 singles. So this is the overall shape. So when I go to draw this, here's my carbon. And adding on to this carbon, I've got this, right? So that's this carbon with these. And now on the other side, I have this carbon. And so with this, I would identify this as a trigonal planar. So out of the choices, this is the only one that will work to have all 6 atoms present and each one with the correct bond need fulfilled. So each hydrogen only has 1 bond, 1 dashed line off of it, and each of the carbons has 4. So you have a double, which means 2 bonds, plus 2 singles. So a total of 4 bonds. Same thing with the red. You have a double, which means 2 bonds, plus the 2 singles, 4 bonds each.